Hello and welcome to another episode of our CosmoQuest office hours. Hello, Michael. I see you out there. I know from my dashboard that there are another four people. We've lost 2 people. Feel free to chime in, say hello. For those of you who are new to this stream, welcome. My name is Dr. Pamela Gay, and with our CosmoQuest office hours, a group of us work to explain to you how it is that, we understand this universe we all share, and we communicate what we know to the audiences around us. Tonight, I'm going to be working on trying to model a star that is in the process of tearing itself apart. Now, normally we do have a slightly larger crew here, so I am going to take just a moment to tweet things out one more time. My Twitter doesn't seem to be updating. That might be part of the problem. Okay, now live. Shredding planets in an animation using processing language. Twitch.tv/CosmoQuestX. Okay, hopefully that will bring a few more people in. Okay, so to give you a summary of what I'm working on. Last week, I asked for suggestions on things that I should work on trying to animate, trying to do data visualizations of. And one of the suggestions that came in was, what about modeling a hot Jupiter that's in the process of getting disrupted? So I did some homework and I looked up to see, do we know any planets that are undergoing this rather hellacious process? And the answer was yes. Yes, we do. And this planet, having the not entirely exciting name of Kelt 9b, is the hottest planet we currently know of. And the reason it's so hot is twofold. First of all, it is currently orbiting, and I have to look at these definitions. It's currently orbiting at 0.03. So this is 3/100ths of the distance of the Earth from the Sun, 0.03 astronomical units. So it's close. And then the other thing that we're dealing with is this is a spectral type AB. So it's on that line between being an A star and a B star. So it's a blue giant star that's sort of hinting its way over towards white. This is a very, very hot star. It's 2.5 times the mass of our sun. And with this combination of planet right next to star big, even though the planet's big, it's working on shredding order of 1 million kilograms to 1 billion kilograms of mass off the planet every single day. Hello, Fenmil. At least I think that's who it is. I need to get a larger chat in front of my face. And I seem to have just banished the screen chat to some hidden location on my screen. There it is. Welcome, Fenmil. So I was just bringing everyone up to speed on, we are going to be working on shredding Kelt 9b. Now, just a few other announcements before I get to doing that. Here at CosmoQuest, in addition to doing our office hours, we have 2 additional shows. Every Monday through Friday at 1 p.m. Eastern, which is 6 p.m. London. And, oh man, unit conversions at the end of the day are getting harder. 10 a.m. Pacific. I go online for 15 to 20 minutes and do a quick roundup of today's news headlines. And Thursdays, at alternating times, I'm going to be doing interviews with various people that help make science and astronomy accessible. And then I'm going to be reviewing products and tune in. It's going to be the late night show of astronomy, maybe a few fewer laughs. I'm not a comedian, but we'll see what we can do. Okay, so thank you, and let's switch over to programming mode. So let me get this out of the way. Now, last week we started the code, and as we got things going, the place that I started was getting a star and a planet that I let you guys give me colors for. I got a star and a planet side by side. Now, when I was originally doing this, I was kind of, I was originally assuming that we were going to be working with a sun mass star. We were going to be working with a normal hot Jupiter. But now that I have a real star to work from, I need to work on correcting these colors. And in addition to correcting these colors, I need to correct my size ratios. Now, I'm actually prepared to do maths. I don't think I'm going to do all the maths at the moment. For now, I want to work on getting my colors correct, and I want to work on trying to get that little planet moving, and then over time we'll work on getting all the scaling correct. Now, the first thing that I want to look at is the parent star has a radius of sorry, I'm hitting my hand on everything right now, has a radius of 2.36. And I'm going to work on bringing up a digital notepad to share with you all. That's going to require me to eat my microphone a little bit more than I'd like. Okay. So this is going to temporarily take the place of my animation. So what I have is the radius of my, none of you can see that. Let me try this again with a bigger tip and in a different place on my screen. There we go. That's visible. Okay, so we're going to start with our, man. I'm going to try this one more time. There we go. We're going to start with R of our alien sun is equal to 2.362 times the radius of the sun. So that's nice, convenient units. This is the Kelt 9b system, Noel. So we now have the radius of the planet. And the radius of the planet is estimated to be, and they aren't being kind to us, 1.9 times the radius of Jupiter. And it's that radius of Jupiter that leads me to say this is not kind. So now I need to look up the radius of Jupiter. X times that is equal to the radius of the sun so that I can do unit conversions. Now, the gorgeous thing about Google is I should be able to come over here and simply type radius of Jupiter in solar radii. And it will just give me these numbers. And for all intents and purposes, Jupiter is 1/10 the size of the sun. So I can say the sun, on the other hand, would be 10 times the mass, 10 times the radius of Jupiter. Which means that we're looking at having a star that is 19 times, sorry, I did that backwards. A star that is we'll call that 0.2 times the radius of the sun. Now I want to get this into a ratio. So if I want to get this into a ratio, what I can do is I can say 0.2 are, how do I want to do this? 0.2 over, so there's my radius of my planet, 0.2 over 2.362 is equal to some number over 1. So I want to set my star, let's do star, equal to 1 and figure out what my planet's radius should be. So in this case, it's pretty straightforward. Jupiter has a super convenient diameter. I can't tell you how awesome every time I look this up, I find it yet again to be. It's a bit sad that I'm incapable of remembering such an awesome ratio. Nonetheless, this is what it is. So with this, my ratio between my star and my planet is 0.08. So the planet is 0.08 times the radius of the star. Now that was a whole lot of calculations. May not have made a ton of sense. I hid my math on you. Did not mean to do that. Sorry. So here what we have is the star that I looked up is, I'm using very confusing nomenclature. The star that I looked up has a radius of 2.362 times the radius of our sun. The planet that we're working on has a radius of 1.9 times the radius of Jupiter, which is essentially 0.2 times the radius of the sun. I did some unit conversions and I figured out that the ratio between this new star, if we set its radius equal to 1, then the planet is going to be 0.08 times the radius of the star. Now the neat thing about this is, because we're looking at a bigger star and we're looking at a bigger planet, our ratio hasn't changed that much. So the math on this should be pretty straightforward. Okay, let me banish that. So looking through my code, I set a whole bunch of variables up at the top, and then I defined them down here. I think I'm looking for where I defined sun radius. There it is. So sun radius I set to be the height of my window divided by 4. I'm going to actually increase the size of my planet because I can. And now when I set my planetary radius, I want to set this to 0.8. Are you going to make fun of my maths? Okay, so let's see what that gets us. So we have tiny planet next to giant star. Hey, Uncle Bill. So the next thing I want to do is, as I showed you earlier, the Kelt 9b system has a big old blue star, and it has an alkali planet hanging out next to it. Actually, sorry, that's a sulfur planet hanging out next to it. So let me reduce this away. And the first thing I'm going to do is take my handy dandy planet. You guys have amazing emote game going on in there. So the first thing that I'm going to do is I'm going to make my planet a new shade of blue. So I'm going to pull up some HTML color codes, and I'm just going to look through and see what looks good. Now, one thing I can also do is I can look up what the temperature of the star is, or I can look up the color of an A0 star. Color code A0 star. Let's see if that's a thing on the internet. A hex on star colors. That is brilliant. Okay, so we're going to science this. We're going to science the colors out of this. I am, because I have no shame, currently viewing the Wikipedia page on Kelt 9b. And on this fabulous little Wikipedia page, I am able to look up all the details on my little planet and my little star. And here it lists the spectral type of our star as being a B95 or an A0. And this lets me look up roughly what that color code is. The color code is somewhere between this AFC3FF and this BACCFF. So what I'm going to do, this is processing. Welcome, Dr. Azur. Is that how you say your name? Welcome. And let me make sure I can keep track of what's going on in the stream. So I'm going to set this star. I can only have so many things in front of me at once. I'm going to set this star to, I'll try and improvise between those two colors. Oh, I suck at improvising between two colors. I'm just going to go with the color of an A1, and I will improvise my colors with maths later. So I see Michael asking a question. Wouldn't it be more general to express everything in solar radii? Then you could plug in the numbers for any system without needing to recalculate ratios. That would probably be true, but I already did it this way because sometimes I don't think ahead all of the way the first try. Michael, I need to have your ability to remember to take things all the way down to the most basic level, like living in my head. This is a form of refactoring that I always end up doing when I get to the end and I get tired of doing these things. Anyways, color codes for stars, they're a thing. I'm going to draw my color, and here is the fill color. I'm going to do this in RGB, which I guess I can do in my head a lot better than I can do the other. So that's going to be 215. So what I'm doing is I'm very rough. Nope, I can't read is what I'm doing. What I'm trying to do is average between these two values, just kind of guesstimate style. It's RGB codes. It's not going to be precise. And that's because this star's spectral type is partway between these two. Now, in order to adjust the limb darkening on this, I'm going to give it nothing but blues on the limb darkening. So I'm going to make this one here 255. Now when I play it, I should have a blue star. And I do. So we got a blue star. Yeah, Michael, you have a few years on me. I'll get there, and hopefully I'll be as good as you when I do. Okay, so now the next thing that's going to be on my list of things to do is to adjust the color of my planet. Now, one of the things I know is the temperature of my planet. It actually has that in the Wikipedia information. And I can use the temperature to get at the color code for this by looking up what type of star has a color of 4050. So I'm going to look this up. What kind of star is 4050 Kelvin? Star classification. You're gonna send me to a chart somewhere, and I'm okay with reading charts. None of these charts. Okay, so what I want is a temperature magnitude diagram. Okay, here we go. Give that to me bigger. You're still not giving it to me bigger. Okay, so at 450 degrees, what we're looking at is that would be about a K4. So I will look this up and verify in a moment by doing temperatures of K stars. Yeah, so we're looking at about a K4. We'll do it. So for the color of my planet, I can do a scientifically guesstimated, oh, I overlaid my planet with a different color. I can do a scientifically guesstimated 255 to 15174. And let's see how that looks. So this thing is quite hot. If your planet is hot enough, you should be able to assume it emits black body radiation. That is exactly what I'm doing, Michael. So because I have color codes for different spectral types, I'm assuming that since stars are black bodies, and I can look up their color code, that a planet at the same temperature is going to have the exact same color code. Now, the difference between how a star and a planet ends up at the exact same temperature is the star has an extraordinarily hot core and is radiating light outwards, heating its outer envelope. The planet has a somewhat colder interior and is getting the bejesus heated out of it by this nearby blue star. Yes, this is true. This is a back of the envelope calculation, Pamela. That's an excellent point. So I now have my little tiny hot planet. Now, the cool thing about this particular planet, and I'm going to enlarge this entire system just a little bit more. Where did I put that? I'm going to make this half the radius. Okay. So at this point, I have the planet is getting ready to pass in front of the star. I will bump it back out so that it's not quite there. Let's do a 10th. So that's exactly what I was going to get to in a moment, Michael, is my planet, because it's so close to its star, is stuck there. Well, it's of course stuck to the planet, but the thing that's actually stuck this time is its orientation. Now, in order to try and explain this, I'm going to stick a stick on my planet while we're working on this so that we can keep track of what's going on. So this is going to be one of the least exciting things I have ever drawn. I'm going to draw it in white, I hope. I always feel like I'm tempting fate when I select stroke colors. I'm going to do a stroke weight of 2 to make it a thick line. And I'm going to draw my line going from the center of my planet to I'm going to keep it at the exact same Y height, but for now I'm going to do planet X. I'm going that direction, so let's do plus 20 pixels, and that will become a variable once I get the line drawing correctly. Okay, I drew an extraordinarily unexciting stick that doesn't show up very well. So I'm going to instead draw it in a horrible shade of green that Pamela likes to suggest every single time. So you're going to get your horrible shade of green because it shows up so well. I'm going to do this as a stroke of 3. And when I'm done, I'm going to put my stroke color back to black. Okay. Now I'm going to put my stroke weight. That's the one I didn't want to change. Back to 1. Ooh, now I have fluorescent green everywhere. I have to put the stroke, wow, I truly have green everywhere. Let's put the stroke color back to where it started too. 0. It's a lovely shade of green for okra. I agree. Okay. Hello, science. Hello, Koku. I think that might be how you say your name. Welcome. Okay, so I have my star. I have my planet. I have a stick on my planet. The reason I have a stick on my planet is so that I can locate which way things are pointing. Now, now that I'm looking at it, I lied. I don't want the stick to actually start at the center. I want the stick to start at the radius of the planet, and this will also end up moving as we go. Wow, that was wrong. I think my radius somehow became a diameter somewhere. Why, yes. Yes, it did. I will rename variables later. Okay, so the reason I drew that is because later on, as this planet goes around and around this star, it's going to keep its little green stick constantly pointed at the star. Oh, it's Zoiku? Did I totally destroy that? So feel free to ask science questions. If you @ me, CosmoQuest X, I'm more likely to see your questions quickly in the corner of my eye over there. So what we're doing is going through and trying to model the Kelp 9b system. Now, with a planet that always keeps the exact same face facing its star, we're going to end up with all sorts of weird, thank you, I'm glad it was close enough. We're going to end up with all sorts of weird thermal conditions on this particular planet. Now, its average temperature is this 4,500 that we looked up. It's actually a bit hotter, closer to the star, a bit cooler away from the star. But with this kind of a temperature difference between the two sides, you're going to end up with these massive thermals that cause the atmosphere to constantly circulate. You're going to have high winds. Life isn't going to happen anywhere on this particular world. But I should, if I can, take into consideration these thermal differences in how I draw this. Now, as I said before, I am using the processing programming language, and I seem to have closed my help window. So what I'm going to look up is how to do a gradient. Hey, thank you, Fenmil, for gifting the sub. That's awesome. Welcome to Team Rocket. You now have a rocket moon that you can play with as an emoji. I hope we see you back here often. Okay, so I'm looking up how to draw a color gradient in the processing reference. Now, processing has one of the best sets of references that I've pretty much ever seen. What I'm looking for now, and I'm just going to search for it, is how to draw gradients. And I know there's a way to do it. It may just mean that I have to draw a whole bunch of lines. Yes, it looks like I'm going to have to draw a whole bunch of individual lines, which is a rather self-hating thing to do. So I'm going to Google processing gradient, linear gradient. Okay, so there is a way to do it. Beautiful. So you set your different colors, and then thank you, whatever just triggered the noise. Thank you for the follow, Koiku. Koiku. Oh, dang it. I had it a moment ago and now it's gone. Yeah, Michael, this temperature gradient is a little bit insane. Okay, so this tells me how to set my color gradient. Oh, man. So simple linear gradient. Yeah, they have you just coding it. I'm going to be too lazy to do that right now. Thank you for the moon and the rockets. Oh, that's excellent. So the question is it X or is it Chi? Because I've been reading way too much Greek, and Chi would just be so cool if it's Chi. X is cool too. Don't get me wrong. I am a fan of my X-Men. But anyways, I am distracting myself from my coding. Yeah. It doesn't want to easily do gradients, but one of the tricks that I've used before is to do a loop. And what I'm going to do here is I'm going to do a loop for just half of my circle, and it's going to be a closed loop. And the reason I'm going to take the time to program this is if I can change how this works as the planet goes around the star, it will make it even more understandable over time. First, I just want to get it working stationary. We're going to do everything one step at a time. And with that one step at a time, it's just easier to follow. Okay, so the first thing that I want to do, I have my bright peach colored planet. And what I want to do is color half of it with an arc. And I shall do this in like pure red. I'm going to use all the awful colors right now. Now, the way I'm going to do this is I'm going to find, so here's my draw planet. I'm going to delete these notes because they are now full of lies. I will fix my comments later. I'm going to fix my comments now to show that I love my future self. Always comment unless you hate yourself, which of course is a valid option. It's just not a preferable option. So I'm going to actually just look at the notes I have on my note paper. So we have our planet is 0.08 radius of star. I'm going to come up here to where I'm drawing sun, which in this case is Celt B. And just to keep consistent notes for myself, this is 2.362 solar radii. So radius of the sun is the way we put it. Now, if you're wondering about some of the symbols that I used when I was handwriting earlier, when we're writing about space, astronomers reduce ourselves to a shorthand because otherwise we're going to be writing for a long time. And we just borrow the symbols the Greeks came up with. I know it's like Western biased and everything, but it's hard to defeat 3,000 years of history. Kai is ocean in Hawaiian, so that works for me. That's very cool. Which island are you on? I hope you're far, far away from the one that Pele is currently quite angry at. Okay. Coming back to drawing my ellipse and trying to talk to you at once. You are all so interesting, and the code is so interesting. There's too much interesting going on. The color code I used for the planet is that for an K4 star. It's a little bit blander than I'd like, but you can't fight black bodies. They are what they are. Okay, so I'm going to adjust my fill color to be an obnoxious shade of red so I can make sure I'm drawing my arc. And I don't have to put all three of those zeros there. It's just a crazy habit I got into somewhere. Now, when drawing an arc, I want to give it a bunch of different numbers, and I'm going to look up what those different numbers are. I think it's the X and Y axis. Yeah, so we have the X coordinate, the Y coordinate, the width, and the height. So I want to do my arc at all of these things. Then the angle that I want to start at and the angle that I want to end at. So to make this halfway easy, I'm going to come up here and I'm going to say, let's go from 0 to pi plus a quarter pi. That did not go as planned. 0 to pi. Okay, that's the font I have today. I updated this code today, and so some of the fonts have changed, and it's amazing how your brain gets trained to know what fonts should be. I'm using processing. It's a bastard version of Java that has a bunch of really nice built-in libraries just for doing video work. Well, I'm glad for wherever you are, Kai. It's probably much cheaper wherever you are, because Hawaii, while beautiful, is quite expensive. Yeah, and you're not dealing with the volcano insurance premiums. Okay, that did not draw as planned at all. So I tried to do from 0. So I guess 0 isn't where I thought it was. 0 appears to be where my little green line is. That is not where I would have put 0, but that's a reasonable place to put 0. So let's try going from 0 to a quarter pi. Let's see if I can narrow down. Okay, so that is indeed where 0 is. Now I'm going to go from 0 to pi, and I should go from 3 o'clock to 6 o'clock. No, I went from 3 o'clock to 9 o'clock because I can't math to save my life. So pi divided by 2 should be what I actually want. Yes, that is what I actually wanted. Now, if I want to start at noon, I think that means the way they're doing this, that I have to do pi plus 3 divided by 4 times pi. I'm sure they have special characters for that. I'm just going to no, that did not work at all. Okay, let's try just going from 2 pi, 2 times pi, to pi divided by 2. Also did not work. Oh, this is fascinating. How do I start earlier? Minus pi divided by 2. There we go. Okay, so you have to do negative. I have defeated it. Yeah, Michael got it the same time I did. Oahu's a beautiful island. Honolulu has a pollution problem, but it's still quite beautiful. The poverty, though, is just so extreme. Yeah. Thank you, Takiko, for hosting us over. Thank you so much. Okay, so we have figured out how to draw on half of our world. Now, that was lame, to say the least. But it was a thing. Now, if what I want to do is highlight the side of the world that's a little bit hotter, what I can do is, instead of drawing this truly hideous shade of red, I can look back over at my color codes. I can just pull the color code for a slightly warmer star, or slightly cooler, warmer. I want warmer, slightly warmer star. Man, at the end of the day, all language skills go away. And I don't know about the rest of you programmers, but I sometimes feel like the part of my brain that is responsible for talking like a human just goes away when I'm programming. Okay, that was overkill. I now drew a really, really ugly planet. Let's draw, and I can move things around so that you can see my ugly planet. It should be a bit bluer. You think a bit bluer than what I drew, actually? Maybe it's time to start figuring out the gradient itself. So the way I did a gradient before is I just did a series of the outer stroke on continually smaller radii. So what I want to do is instead say stroke that, no fill. I think that's a thing. And this should just draw a single arc. Yes, you can just make out there's an arc right there. Now what I should be able to do, if I figure this out right, and let me share with you where I can draw what it is I'm thinking of doing. I need to turn back on my screen sharing. So I have over here a iPad Pro that is much, much beloved, that I have a Apple Pencil for. And what this lets me do is I can draw things. And what I'm going to draw right now is, so let's say I have a planet. That is a horrible planet, but this particular software allows me to force it to do better for me. So there is a much better planet. And I can even bring that much better planet better into view. Now currently, the majority of it is filled in this light peach color. So there is the majority of my world filled in a peach color. Now what I want to do is start adding color to this to show that this is super hot. Now I want to somehow figure out how to do this so that it's a smooth gradation. So what I probably want to do is, this is very hot, then maybe this. I need to figure out the correct way to transition, because what I want to end up with is a fairly smooth continuation of color. I'm going to fail at this miserably the first few times, but that's okay. So the first thing I'm going to do is I'm going to cheat, and I'm going to do this the easy way that's going to look somewhat dumb. So the way I'm going to do it initially is just a gradient of colors, kind of like this. And once I have it doing this, I will figure things out in more complicated ways. Does that make sense to people? Draw very small arcs while ramping the color. Michael, you're like reading my mind and putting your thoughts into my mind while I think and read. It's nice to know that at least I'm kind of keeping up with you here. Okay, so let's start by creating a loop. Now I've been just using I for doing my loops because, hey, it's a letter. It's a letter I've already declared and I can use. I want to do all of this except for the no fill inside the loop and change the values. So I'm going to set my no-fill outside of a loop. Because I like myself, I'm going to say this is shading of the planet. I'm going to do I'm just going to copy and paste because I'm lazy. And I'm going to have it go from 0 to n equals the planet's radius, which might be its diameter. Your language skill is constant struggle. That's sad. My brain doesn't like to mode switch. So sometimes when I'm drawing, it's just like, nope, you're not allowed to be able to do anything else. When I'm coding, it nopes me the exact same way. Okay, so back to my loop. I have a loop. In my loop, I'm going to set the values for my arc. And my planet started at 255, 215, 174. So let's make those variables. So I'm going to declare all my variables up top so it's not doing it over and over and over. So I'm going to do planet R for R color. I'm going to do int. Wow, can't type. Int planet RG. I'm going to do int planet B. And now, coming down here and setting up my planet, I'm going to set all of these things. So my planet R is going to be equal to 255. My planet G is going to be equal to 215. My planet, I screwed up my variable names. G, B. Now the only reason I put the underscore there, and they are not proper for this language at all, neither is capitalizing planet, but the planet is a proper noun in my universe today. And I put the underscore in to enhance readability. Sometimes you have to break style to make your code readable. Do what you can to be able to easily move through your code and understand what's going on. So you can tell that I'm used to using IDEs that autocomplete my variable names for me because I have no fear of long variable names. It just means I get extra typing skills today. Now, what I want to do is go from my original hot temperature back to that. Now, I had a 255 before, so that one's not going to change. So I have an upset dog. Something deeply offended him. So I'm going to start at, let's start at planet G minus n plus I. I'm making shit up as I go. And then I want to get to 255 from 174. This isn't going to be enough, but let's just see what happens with this. Okay, so we are doing guesstimations. RGB. We're doing guesstimations here. Thank you for catching me, Keeper of Maps. Too many characters. What did I do? Oh, I didn't close the right one. That implies I did something very wrong somewhere. What did I do wrong? Arc. Okay, get mad at me again so I can find the mistake. Found one too many blank characters. Yeah, I am missing one of those. Oh, you're trying to add it in for me and I'm being belligerent. Okay. There needs to be one below this. Cannot be resolved to a variable because I can't spell. There we go. Oh man, that did not work as planned. Okay, so I'm going to set my R to 0 so I can better see the mess. That did not go nearly enough times. I equals 0, I less than n, I plus plus. N is set equal to the planet's radius. Oh, I never changed the radius of the arc. That would be why. Okay, I just kept drawing the same line over and over and over, and that doesn't work. Okay, stupid typos. There we go. So my color is not changing nearly enough. So why is that? So let's try just... So my planet's G value is 215. So let's add I. I just want to make sure I have my loops working. And then I'll math the loops better. This is where I typically say I hate everything. Let's simply do I and I. I equals 0. I less than n. I plus plus. You went more than once. Let's do I times 5 because that's so tiny and maybe that's the problem. Yes, that was the problem. Okay, so what's happening here? And I'm going to increase the size of my planet so that we can see things better. Because I don't know about you, but my eyes are hating me right now. There we go. So what I had done wrong was, since the radius is so small, I needed a multiplier in here somewhere. So now I just need to find the sensible multiplier. I'm drawing as many arcs as there are pixels of diameter. Let me echo. Let me print. I need to look up the syntax on this because I don't use this language nearly enough. Let me look up the syntax to print out my n value. Print. No. Let's try echo. Print. There we go. No, you're not being useful. Output. It wants to output a text area instead of output the information. Have you thought of using K, 1 minus K interpolation between the colors? I have. I was just trying to make it lazy first. Right now I'm just trying to figure out how to get it to output my n value. So down here I have an area where it can output information for me, but I have figured out how to do this before. Okay, this is where I just flat out Google processing output to console. Print. It says use print. Okay, I'm going to go with that. Print n. So it should print the exact same thing a million times. Yeah, so 240. I'm currently doing it 240 times. Keeper of maps, don't make all of us want pizza. That's mean. Okay, so it's just going to keep, stop, you can stop. I'm going to kill that. I'll put a flag on it later or something. Okay, so this is where pizza is always a valid answer, Noel. You clearly haven't lived if you don't know exactly what time you can order pizza to from your local pizza joint. Okay, so here's where I'm going to leave myself messages. Goal. Go from starting color, and I'm going to put my RGB values here once I find the window where I hid them. So we're going to go from a temperature of a fairly realistic 255, 249, 249 to, and I'm going to rearrange my comments a little bit so I can just line up all of my stuff to, I want an end color 255 on the cold side, 235, 209. Actually, I want to use the numbers I have above, 215, 174. So this is the number I want to do. So this means I need to have an int delta G, which is equal to 249 minus 215. I also have an int delta B, which is equal to 249 minus 174. And this is, if I want to turn this into the delta that I move each step, it's going to be that delta divided by n. So what this means is this is the total amount of change that I want to do, and I want to do it in a total of n steps. We have an ent. I'm a fan of ents. You should be able to get pizza at 3 a.m. You should totally be able to get pizza at 3 a.m. I've never heard the never pay full price for late pizza. I'm glad you're here, Michael. And I guess where you are, you don't get 3 a.m. pizza, you get 3 a.m. kebab. I've done that in London. I had regrets. And my turtle still hasn't learned that it can't jump. Thank you for the 11 bits. That's fabulous. Artsy Passion is here. What time is it where you are? Our world rotates. It's kind of annoying that way. Okay, so I want to work on changing my colors. Thank you so much, Fenmill. That's awesome. You make me so happy. Okay, so I'm going to figure this out and then call it an end until next week. Okay, so I'm going to start at starting color is math. Math is hard. I'm going to totally do this backwards the first time. I want to start at, so that's how much I move each time. I want to start at planet underscore R plus delta G, and I'm going to have to run my radius cycle backwards. So I'm going to start at radius I minus n and then add an I so that I can get the colors to work. I know that looks stupid. I don't care. I just want it to work right now, and I will optimize later. And Michael Myers is probably sitting there cringing on the edge of his bed at the horrible thing I just did. Planet, so stroke is, I'm doing the fill colors here. Stroke. My turtle keeps jumping. Why is my turtle jumping? Is planet R, is planet, not planet R, is planet R, is planet G plus delta G is planet B plus delta B. Please work. It did not work at all. That makes me so sad. Okay, so let's start by seeing if I screwed up there by doing crazy maths. No, so that's not the problem, and this should have had a minus sign. Minus I. Okay, so I've my colors planet R, and I'm gonna do, oh, I forgot the I. Strangely enough, if you don't increment on your color, nothing happens. I'm glad I didn't disturb you. Why are you still not iterating on the color? Okay, so let's try just doing that. And I'm going to hand math it, so this should be 249 plus delta divided by delta G. This should be, that should be okay that it's an int. It might not be. That might be what's killing me as I inted things. So this should be 249. No, that's a lie. That should be 174 plus, and this should be 215 plus. Please be a gradient. Please be a gradient. You are not a gradient. My code hates me. Okay, so here is where I try and find out why it hates me. Print del G plus del B. Did I do those in the wrong order? RGB. No, I didn't. Plus, let's just throw another space in there for good measure and make sure we have all the plus signs. Okay. Oh, yeah, so those can't be ints. That was my problem. That was a really stupid problem. Okay. May the floats be with you. Float. Seriously, float. So del B equals 0.0. Yes, Michael, I need to make these all variables. I now have your voice in the back of my head yelling at me in a very polite and British way. I know you're not actually British. Every time I code something dumb. Yes, I now have a gradient. I have a gradient that is a inverse of the gradient I need, but I have a gradient. And I should be able to rather easily stop. I should be able to rather easily fix that so that it's planet radius minus n plus I, and it's planet radius minus n plus I. Yes, it's ugly, but I got it. That is entirely true, Fenmil. What always gets me is, so I took a bunch of computer science classes as an undergrad. I didn't quite finish my undergraduate degree in computer science because I honestly couldn't do one more homework assignment that was centered on hockey. I'd had the same professor over and over, and I swear the majority of his homework was related to hockey, and I don't care. I don't care. I'm sorry, Canadians, I don't care. And when I found out the same professor was going to be teaching assembly, which was my next required course, I just noped it. I noped it so hard. And so I did not quite finish my computer science degree. But what I took completely changed how I code. And one of the things that concerns me a lot is I see how my computer science undergraduates come out knowing stuff. They're sharp, they can code, they get all the quick little turns that you can do to make things work better. And our astronomy PhDs on our team are amazing. They do great science, but they're still learning all those tricks of the trade for programming. And so it really is worthwhile to hire that one undergrad computer scientist sometime to make that world of a difference. Okay, so any last minute questions before I close this down for the night and prep to go do other things? Okay, I do not have Slack open. Let me find where I have Slack. So Noel is a professional animator who is doing things the professional animating way, which is not what I'm doing. So he's been working on the same thing, and I'm looking to see where it is. Slack is being slow. Where it is on my other screen. So, Noel, you need to do Cosmic Latte superimposed on a black background. So this is what Noel has so far accomplished. But he's using something with built-in gradients, which is awesome. You're doing really well. Okay, so next week I'm going to continue doing the exact same stuff, the exact same bat time, bat channel, and my goal is to work through this, get all the gradients working right, and then figure out, once I have complete control over my drawing of arcs and things, I'm going to stick them in a routine so that I can alter where the center and the edge points are as I move my planet around the star. So there's going to be times where we don't see any gradient in the color because the planet is completely in front of the star, the planet is behind the star. But while I work on getting to that point, we're going to fill in all these little gaps, and I'm going to explain them and the science to you as we go. So thank you so much for joining me. Thank you so much for the bits and the gifted subscription, Fenmil. Thank you so much for joining us, Kai. And all of you out there, Hirotoxico. I don't know how it's actually pronounced. I'm sorry. Thanks for the host over, and thank you, Rocket Sage, for the follow. It's been a great evening, and remember, tomorrow we're going to have your daily space coming to you live from wherever I happen to be at 1 p.m. Eastern, 6 p.m. London, and that is 10 a.m. out on the West Coast. So I hope to see you then, and wherever you are in the world. Michael, go to bed or go get a snack. Thank you for joining us wherever you are in the world, and have a great morning, evening, afternoon, and wonderful dreams when you get there. Bye-bye.